Hi everyone, for today's video, we are going to solve the problem 7.1. So for the given state of stress, determine the normal and shearing stress exerted on the oblique face of the shaded triangular element shown. Use a method of analysis based on the equilibrium of that element as was done in the derivations of section 7.2. So this is the given figure. And we have to solve the normal and shearing stress. So these are the stresses, areas, and forces from that given figure. So for the stresses, we have 120 megapascal, 45 megapascal, and 60 megapascal with a degree of 20 degrees. For our areas, we have A cosine 20 degrees and A sine 20 degrees. For our forces, we have 120A cosine of 20 degrees, 45A cosine of 20 degrees, 45A sine of 20 degrees, and 60A sine of 20 degrees. So these are the FBD for our stresses, areas, and our forces. So this is the solution in finding the normal stress from the given derivation of section 7.2. So sigma A minus 120A cosine of 20 degrees cosine of 20 degrees minus 45A cosine of 20 degrees sine of 20 degrees minus 45A sine of 20 degrees cosine of 20 degrees minus 60A sine of 20 degrees sine of 20 degrees is equal to 0. Transposing this equation into the right side, we have changing its signs. We have sigma is equal to 120 cosine of 20 degrees plus 45 cosine of 20 sine of 20 degrees plus 45 sine of 20 degrees cosine of 20 degrees plus 60 sine squared 20 degrees. So we have a final answer for our normal stress, or we have the value for our normal stress, which is 14.19 megapascal. So this is the solution in finding our shearing stress. So we have tau A plus 120A cosine of 20 sine of 20 degrees minus 45A cosine of 20 degrees cosine of 20 degrees plus 45A sine of 20 degrees sine of 20 degrees minus 60A sine of 20 degrees cosine of 20 degrees is equal to 0. So transposing these equations into the right side, changing its signs, we have tau is equal to negative 120 cosine of 20 degrees sine of 20 degrees plus 45 times cosine squared 20 minus sine squared 20 degrees plus 60 sine of 20 degrees cosine of 20 degrees. So we have the value for our shearing stress, which is 15.19 megapascal. So these are the values, or these are the solution in solving the problem 7.1.